Good afternoon, all.
Good afternoon.
Good afternoon.
Okay, so did you turn your page? Yes. So yesterday, what we have learned? Did we learn anything? Huh? Yes. So we have started a chapter, isn't it? Yes.
Yes, ma'am.
Yeah. So, what is the name of the chapter? Excellent. What is the name of the chapter?
Computer system organization.
Yes. If you can't, if you are not able to say the name of the chapter, that means you have not gone through it, isn't it? Huh? But the concepts are familiar. So let's revise the topics from the starting. After that, there will be a question. I will display a question paper. You have to answer that. Is that clear? After that, we will move on to the next topic. So let's revise. So yesterday we have started this chapter. Then we have gone through some of the basic information regarding the computer, isn't it? From here our topic has been started. So what is a computer? It is an electronic device which accepts a set of instruction, isn't it, in the form of a program. Then it does the execution and we will get the output, isn't it? This is how a computer works. Next, then we have gone through the concept called data and information. So what is data? The raw facts of figures is known as data. Here you can see some of the example of the data, isn't it? So what is information? It is a collection of data which has been organized in a proper manner, isn't it, to generate a meaningful or processed data. So here you can see one example of information. Then we have learned about information processing system. Not system, it is cycle. What is that? You all know that the computer takes input in the form of data and it generates output in the form of information, isn't it? So the process of converting this data into some useful information, some meaningful information, is known as information processing cycle, right? Then we have learned that which are the basic parts of a computer? Hardware and software. So what is hardware? The physical part of a computer is known as hardware, right? And while coming to the software, these are the set of instructions or program which has been given to a computer. Then we have gone through IPO cycle. IPO stands for what?
Information processing output.
Okay, so in this, from this figure it is clear that we get the input in the form of data. We used to enter the input in the form of data and we get the output in the form of information, and there is memory unit which is used for storing the intermediate result, isn't it? So IPO, I stands for input, P stands for process and O stands for output. Okay, so here there is a unit called memory unit which holds the data and instruction during the processing. Okay, who does the processing? CPU. CPU stands for Central Processing Unit. Yes. So this is the von Neumann's architecture in which we will get a complete idea about a computer system, isn't it? So from here we could get that we get to know that the computer receives the data through input device, isn't it? And the processing has been done by CPU. CPU stands for Central Processing Unit, isn't it? There are two types of memory. Main memory is also known as primary memory and second one is secondary. It is also known as auxiliary memory. What is the use of that? It is used for storing data, right? Then what is the role of the main memory? It holds the input and the intermediate output during the processing. There should be someone to hold the intermediate result and the input, isn't it? So main memory does that. Then we have learned about input unit. So what is the input unit? It accepts or it takes input and it converts it into binary form, which has been understood by the computer. You know that computer can understand only binary language, isn't it? Yes. So binary means two states. There are two states. It can be on or off, or high or low, isn't it? On represents 1 and 0 represents off. Yes? Yes or no?
Yes, ma'am.
Then what is the definition for the input unit? The unit which fetches the input and converts it into binary form, which has been understood by the computer. So we have gone through some of the input devices. First one is keyboard, then mouse, then light pen. After that OMR, it stands for optical mark reader. Then smart card reader, barcode reader, QR code reader, biometric sensor, then touch screen, microphone, webcam, and magnetic ink character reader, isn't it? Till here we have discussed in the last class, right? Now are you ready for a small test?
Yes, ma'am.
Yes, geez. I think you are attending for the first time, right? You were not there. Yes, my dear? Okay. So, this is all about simple topics. Please try to answer this question and please do write, because this is important. Yes, try to answer this question. These are the simple basic questions. Try. I'll be giving you 5 minutes. Try to answer. If it is over, let me know. Is it over?
Yes, ma'am.
Now try this. Over? I think it is over, right? Okay. So, moving to the first question, I would like to ask Pooja. What is the answer for the first one, my dear? A computer is an? So, which option? Option A, right. A or B? A. Next, for Tom, second one.
A computer takes input, processes it, and gives output.
So, which is the option?
The third one.
Very good. Yes. Next question is for Anaga. Easy question. CP stands for? Option B. Yes, Central Processing Unit. Next one for Naureen.
Option C, input devices.
The devices which feed data into computer are called input devices. Okay, very good. John Joes. Fifth one, example of input devices.
D all of the above.
Yes, because keyboard, scanner and microphone is an example for input device, isn't it? Next. John Philip. The full form of IPO.
Input process out.
Which option?
Option 1.
Excellent. Now, geez, I know that you were not present. Try to answer the seventh one. MICR. Do you know? Huh? No. Okay, then Niranjan. Niranjan, are you there? And Renil? Are you there?
Yes, ma'am.
Yes, what is the answer? MICR stands for
Magnetic ink reader.
magnetic
Ink
ink
character
character.
reader.
Yes, character reader. Excellent. Next, I would like to call again Tom. QCR stands for
QC,
not Q, it is OCR. Sorry, it is O.
optical character reader.
Yes, it is optical character reader, isn't it? Optical character reader. Next. Yes, again Pooja. QR code is an abbreviation for. Yes, can you just repeat? Yes, quick response. What about the last one? What about the last one? Anyone can answer.
OMR,
OMR. It stands for?
optical mark reader.
Okay, optical mark reader. It was easy question paper, isn't it? Yes? So we are moving to the next topic. Before that, let me ask you one question. What do you know about a CPU? What do you know about a CPU? Yes. Nothing.
Brain of the computer.
Okay, then. Then. All the major comparisons and calculations are being done inside the CPU, isn't it? Yes? CPU stands
Yes,
for?
ma'am.
CPU stands for
Central Processing Unit.
Central Processing Unit. So today we will be covering about CPU. So CPU stands for Central Processing Unit. So it is the control. It controls the set. It is a control center brain. Okay, it is known as the brain of the computer. Okay, it is known as the control center or brain of a computer. It is the control center or brain of a computer. It is known as the brain of the computer, isn't it? Why? All the major calculations and comparisons are being done in the CPU, right? So it is responsible for activation and controlling the operations of other unit. So it directs, controls all the processing that takes place inside the computer. We used to say that CPU is the one who coordinates all the parts of the computer, isn't it? So this is known as the brain of the computer. It is the main part of a computer which coordinates all the activities, okay? Who does all the calculations, all the comparisons are being done in this CPU. So CPU is responsible for the activation and controlling the operations of other units. So basically there are three components of CPU: ALU, MU and CU. Okay? Moving to the first one, ALU stands for Arithmetic Logic Unit. You all know that. Can you just explain what happens in this unit? Yes? All the arithmetic operations. Which are the different types of arithmetic operations?
Addition, subtraction.
Yes, all the arithmetic operation and logical operations are being done in this unit. Okay, here all the calculations and comparisons are made in this unit, and it performs arithmetic, which means that in your maths you used to do plus, minus, division and all, isn't it? And logical operation. Which are the logical operations? Logical or, logical and. Have you learned that in your maths? Huh? No. Huh? Okay, so this unit performs all the calculation and all the comparison. Okay, is that clear? And result of the logical operation can be either true or false. It contains only two values. The result can be only two. It can be either true or false. If it is true, it represents 1 or 0. Okay, so all the major calculations are being done inside this. And the result has been stored in the memory. So first unit is ALU. ALU stands for Arithmetic Logic Unit. All the major calculations are being done and all the major comparisons are being done in this unit, isn't it? We used to say that CPU does the calculation. So which unit of CPU does this? Which unit of CPU does this operation? Which unit? ALU. ALU stands for Arithmetic Logic Unit. Okay, so the result of the logical operation can either be 0 or 1. Is that clear? Is that clear or not?
Yes, ma'am.
Yes, ma'am.
Next is control unit. From this word, you can guess what is the use of this unit. What is the use of this unit? All the entire operations of the computer is being controlled by this unit. It controls the flow of the data from input device to memory and from memory to output device. So all the operations has been controlled by this unit, isn't it? It also controls all devices such as memory, input, output devices, which has been connected to the CPU. So all the devices which has been connected to the CPU has been controlled by whom? This unit, which is known as control unit. And it doesn't process the data. This unit doesn't process the data. Instead of that, it sends signal to the ALU and memory for carrying out the required operation. It only sends the signal. It doesn't do any calculation. It doesn't process the data. Okay. Is that clear? Yes. So CU, this is the second unit of the computer. CU stands for control unit, and it controls the entire operation of the computer. This unit is responsible for controlling all the units of the computer, isn't it? So it also controls all the devices such as memory, input, output, which has been connected to the CPU. Yes. So next concept is registers. There should be temporary storage area, isn't it, in the CPU, so that it can store intermediate results and data for at the time of processing. So registers is the temporary storage area which has been found in the CPU. Okay, so registers is the temporary storage area which has been found in the CPU, and it works according to the instruction which has been given by CU. It works according to the instruction which has been given by CU. CU stands for
Control unit.
control unit, and it stores. So what is the main role of the register? It stores the instruction and data intermediately which has been required for performing an operation. Okay, so it is used for storing the intermediate data and information which has been required, which has been used for performing an operation. So intermediate results or data are being stored in these registers. So CPU places the highest priority jobs and data inside this register for faster execution, isn't it? In your real-time example, if you take a real-time example, you are standing, okay, you just went to watch a movie. You're just standing in the queue. If our movie comes, what will happen? They will tell us to move, let him enter, isn't it? So the priority has been given to whom? So the chance has been given to whom? To whom? To me? No.
Prime Minister.
Yes. Isn't it? So like that, there is priorities. Okay, there are different types of priority. So CPU places the highest priority jobs or highest priority data inside this register so that we can access it fastly, so that we can fastly execute that job. Okay, so registers can be of different sizes. It can be 16-bit, it can be 32-bit, it can be 64-bit, and so on. Okay, registers are of different size. There is no specified size for the register. It can vary, and each register has a specific function, such as storing data, storing an instruction, storing address of the location in the memory. You know that every data that is being stored in the memory, it has a particular address, isn't it? You all are having address, isn't it? You all are being identified using that address. You are being recognized using that address, isn't it? So a memory is a space in which we can store data. So every data which has been stored in the memory is having a particular address. So these registers help us to store the address of a location in memory. Okay, so these are the different points regarding the register. So basically, what is a register? It is a temporary storage area which has been found in the CPU. Okay, then register works as per the instruction which has been given by the control unit. It stores instructions and data intermediately which has been required for performing an operation. Then CPU places, you know that in register we used to keep data, isn't it? But CPU places the highest priority data or job. It places the highest priority jobs in the register for faster execution, isn't it? Then it has registers are of different sizes. It varies. It can be 16-bit, 34-bit, not 34, it is 32-bit, 64-bit. Okay, then each register has a specific function, like storing data. It can store instruction. It can store address of a location in memory. So we have discussed that registers are the temporary storage areas, okay, which has been where these registers are found inside in the CPU, isn't it? It has been stored. This registers has been stored in the CPU. So what is register? If someone asks what is register, you have to say that it is the temporary storage area. First point. Okay. Then it works. Register works according to the instruction which has been given by which unit? Control unit.
Control unit.
Okay. What is the role of the register? It stores instructions and data immediately required for performing an operation, which means that it stores the intermediate results and data which has been required at a particular period of time. At that time it has been stored at that data and instructions are been stored in registers. Okay, it stores the data temporarily. Then CPU places the highest priority jobs. There are different jobs, isn't it? When we are using, we are multitasking users, isn't it? At the same time, we will be doing different jobs. Can you just give me one example for that? At the same time.
Priority to give an old man to go forward in a queue.
Very good. It is an example for the real-time example. Other than that, when we are using computer, we will be doing at the same time. On the same time, I will be listening to music and I will be doing some works in different applications, isn't it? I will be jumping from one application to another. So at that time, the application that I am opening is the priority one. Okay, so that application which I have opened recently is the priority job there. So that data will be stored where? In the register. Okay, you have seen the register in the school, isn't it? What is the role of that? For storing data, right? Yes? Yeah. Then each register, there are different types of register. You will learn about this in your higher classes. So there are many registers which has a specific function like storing data. It can store data, it can store instruction, it can store address of a location in a memory. Okay, is that clear?
Yes, ma'am.
Yeah. So far we have discussed about CPU. So let's revise the topic once again. CPU stands for Central Processing Unit. You all know that it is known as the brain of the computer, isn't it? All the major calculations and comparisons are being done here. It consists of 3 units: ALU, CU and MU. Okay, ALU stands for Arithmetic Logic Unit, MU stands for Memory Unit and CU stands for Control Unit. Okay, so in the second point you will get to know that it controls all the processing that takes place inside the computer. So it is the one who controls, who does all the performance, all the arithmetic calculations and logical comparisons has been done by this unit. Which is this unit? Which is the part? CPU. And which unit does all the calculations?
ALU.
ALU. Which unit controls all the parts of the computer which has been connected to the CPU?
Control unit.
CU, which means that control unit. So first we have discussed about Arithmetic Logic Unit. In this unit, it does all the calculation and all the comparison and all the calculations are been done in this unit, isn't it? Yes, it performs arithmetic and logical operations and which has been sent from the memory, isn't it? And it performs specific operations and the result is been turned. It has been returned to the memory. So it takes the data, it processes it, it does the calculation and it sends that result back to the memory. Is that clear?
Yes, ma'am.
Yes. And result of logical operations. There will be only 2 results for the logical operation. It can be true or false. So after that, we have discussed about CU. which stands for control unit. It controls the flow, isn't it? It controls the flow, or it controls the entire operation of the CPU. It controls the entire operation of the computer, right? So it controls the flow of the data from input device to the memory and from memory to output device. You know that we used to give input using the input unit is our input device, then processing has been done in the CPU, then we get output using the output unit, isn't it? So the flow from here to here and from here to here is been controlled by this control unit. This has been controlled by which unit? Control unit. Okay, but this unit doesn't process the data. Instead of that, it just sends the signal to ALU and memory for carrying out the required operations. Is that clear? If someone asks, any processing has been done in this unit, you can say no. It just controls, which means that it only sends the signals. Is that clear?
Yes, ma'am.
Okay. Next one is register. Once again, what is register? Temporary storage area, isn't it? Which has been found in the CPU. And registers work according to the instruction given by whom? CU. CU stands for control unit, and it stores instruction and data immediately required for performing an operation. After that, it places the highest priority job and data inside registers for faster execution, and registers can be of different size, it varies, okay, and each register does a specific function. Is that clear?
Yes, ma'am.
Okay, next is memory unit. What is the role of this memory unit? It can be, there are two types of memories in it, primary and secondary. Primary memory is also known as main memory. Is that okay? Yes. So what is the role of the memory unit? It stores data, isn't it? It is the storage unit of the computer. It stores the data. And it is the computer memory which is accessed directly by the CPU. This memory is directly accessed by whom? It is directly accessed by CPU. So memory can be of two types, primary and secondary. So this main memory, which means that primary memory is been accessed by whom? It has been accessed by CPU. And here you could see that there are two types of memory. First one is primary and second one is secondary. Okay, do anyone have any idea about what is primary memory and what is secondary memory? No idea?
Primary and secondary both store data.
Then what is the difference? What is the difference? Primary memory.
Permanent storage in secondary and for temporary storage in that
In which?
primary.
Actually, have you ever heard about this RAM and ROM? These are examples for the primary memory. But a ROM is storing the data permanently, then why? Yes? Any other answers regarding this? So, look at this. So, primary memory is also termed as main memory, okay? This main memory is been accessed by CPU, which means that all the work which has been done in the RAM and stored in the, yes, all the work has been done in that. After that, the storing will be done in the secondary storage, which is hard disk. Okay, RAM stands, what is the full form of RAM? What is the full form of RAM?
Random access memory.
What is that? All the major functions are being done in RAM, isn't it? It stands for random access memory. We are going to learn detail about that. So all the major functions are being done in the where? In the main memory, which is known as primary memory, isn't it? And after that, it has been stored in the secondary storage device. Which is the secondary storage device? Hard disk, which is found inside the computer, isn't it? Yes, nowadays portable hard disk is also available, right? Do you have any secondary storage device? Yes or no? No, you have not seen that portable hard disk. So there is a portable hard disk which is used for storing the data permanently. Okay, so in this case there is an indirect contact between the CPU and hard disk, isn't it? Yes, because the data are being stored in hard disk. Actually we are using the main primary memory, but after the processing the data are being stored in where? In the hard disk, which means that secondary storage device, isn't it? Moving to the next one, that is secondary memory. It is also termed as auxiliary memory. Okay, the data can be accessed by the CPU through input output controllers. Through input output devices we can access the data. So what is the other name for the secondary memory? It is also known as auxiliary memory, or it is also known as auxiliary storage, which includes devices such as hard disk and all. The secondary storage can be accessed by the CPU through input-output controllers or units. Actually, what is a memory? We are using the term memory. What is a memory? What is memory? It is a place where we can store information, isn't it? Or we can say that it is the workspace, isn't it? It is a workspace, right? What is a memory? It is a workspace or working space. So what is a memory? It is a working space where it temporarily keeps information and data to facilitate its working, right? So what is a memory? It is a storage space. It is a workspace where we used to save our data, where we used to keep our data, isn't it? So basically there are two types of memory, primary and secondary. Primary is also known as main memory, and which is directly accessible by CPU. And while coming to the secondary memory, it is also what is the name for that? Auxiliary memory, isn't it? Yes, this memory can be accessed through input-output controllers, which means that input-output units. So, which will be faster, primary or secondary? Which is close to the computer? Primary, right? So, it will be faster. It does the operation faster when we compare it with the secondary memory. Is that clear? Now, so what is memory? Please do write this definition. Memory of the computer is just like a predefined working space where it is a predefined working space where it temporarily keeps information, isn't it? When the task is executed or finished, it clears the memory, and this memory space is available for the next task to be executed. So it is just a temporary space where it stores the data of the current working program, isn't it? After if its execution is finished, then it will be, that space will be assigned to another task. Okay, so when the task is executed or finished, it clears the memory, and this memory space has been available to the next task. Okay, so RAM, which is the primary memory, isn't it? You have heard about RAM, random access memory. This is an example for the primary memory, which consists of cells. Yeah. So what is memory? It is a working space where it stores the data temporarily, which stores the information temporarily. If that particular task is finished, then that space will be assigned to the other task, which means that the data or the information regarding the previous task will be cleared. So RAM, it is a primary memory which is composed of cells. Okay. Is it okay? Yeah. Here you can see the example for the memory cells, isn't it? Here each cell, here you can see different cells. Each cell is been divided into smaller parts, which is known as bit. Here you can see different bit. This is the cell. This is the first cell, and this is the second cell. It goes on, and each cell has been divided into smaller components, which is known as bits. And bit stands for binary digit. It can be either 0 or 1, isn't it? So combination of these bits are used to store data and information. You know that all the data or all the information are been stored in the computer in the form of bits. It can be binary digits, which is 0 or 1, isn't it? Here you can see one example. So it consists of each cell. There are different cells, isn't it? Each cell consists of, it has been broken down into small parts, which is known as, each part is known as cell, isn't it? So the primary memory of a computer is composed of cell. Primary memory is composed of cell, and it has been broken into smaller parts, which is known as bits. Bit can be either 0 or 1. Okay, this is how you know that this is how the way in which the data are being stored in the computer, because this language, only this language is being understood by the computer, right? Does it understand our language?
No.
No. But we are quite smart, isn't it? This is all about memory cell. Is that clear?
Yes, ma'am.
Now, main memory or memory unit are of two types. Primary memory are of two types, which are the RAM and ROM. RAM stands for random access memory, and ROM stands for read-only memory. RAM stands for random access memory, and ROM stands for read-only memory. So these are the memory unit or main memory, which our main memory has been divided into two, RAM and ROM. And you have heard that 8 bits is equal to, which is the measuring unit of the computer, byte, isn't it? 8 bits is known as 1 byte, isn't it? Yes? And 4 bits is equal to 1 nibble. Please note it down. This is the basic unit. This is the unit of measurement. As you have learned in max kilogram, there are different measuring units, isn't it? Kilometer, meter, then kilogram, gram, like that. There are different measuring units in computer. Okay, so 8 bits is equal to 1 byte. 1 byte consists of 8 bits, and 4 bit consists of 1 nibble means 4 bits. Okay, so our main memory has been divided into two, RAM and ROM. RAM stands for random access memory, and ROM stands for read-only memory, isn't it? Now, What is RAM? What do you know about RAM and ROM? Tell me. Nothing. Do you have tattoos in your hand? No. Why?
No.
Because your parents are not allowing. So you have a
My
yes.
taste.
Yes, John.
Not my taste.
Oh, not your taste. So, I was just thinking to relate this concept with that. You have seen that small children are making tattoos using their pen, isn't it? It will be erased. What about the permanent one?
It won't go.
It is just like that. RAM is known as volatile memory, which means that it will data will be erased when there if any power failure occurs. Okay, like our blackboard. Why I am just relating this concept of the RAM with the blackboard? Can anyone explain? Yes. Why? I have told that RAM is a temporary memory, isn't it? Data will be erased if any power failure occurs. So why I am just relating this concept with the blackboard?
The chalk can be dusted off.
Okay, what about others? Any other answer? Any other answer? We have class till what time?
4:30, ma'am.
Is it over? Yes, right? So it's time. We'll meet in the next class. Thank you.